In this lecture, we are going to talk about how to choose among projects. So far, we have learned about investment decision rules for a standalone or an independent project. But in this video, we are going to see how to deal with mutually exclusive projects. So, first of all, why the firm cannot choose all the projects with positive MPVs? Because a project with a positive MPV will increase the value of the firm. The reason is that sometimes the projects are alternative. Choosing one project will prevent us from choosing the other one. For example, let's say you want to buy a personal computer for yourself and you have a certain amount of budget. You can either buy a Mac or a Dell or an HP or other brands that are available in the market. Buying a HP laptop will prevent you from buying a Dell or a Mac computer. So, another example in a corporate setting would be, for example, Tesla wants to choose a design for its for one of its cars. So, let's say Tesla has three designs: A, B, and C. So, choosing one of these design, for example, B, will prevent Tesla from choosing A or C. These projects are called mutually exclusive projects. Um, Formally, two or more projects are mutually exclusive if choosing any of them excludes us from taking the other projects. So, now what is the solution? How can we choose among mutually exclusive projects? The solution is that we need to choose the project with the highest MPV. We're always going to stick with the MPV rule. We are not going to use IRR to choose between projects. So the MPV rule is pretty simple. We are just going to choose um, the highest MPV project given that we have several positive MPV projects. For the IRR rule, we haven't talked about how to choose, how to use IRR rule to choose between projects. So the way to do that is calculating IRR for different projects. So let's say I have two different projects, A and B. So I'm going to calculate their IRRs, IRR for project A and IRR for project B. If IRR for project A is larger than IRR for project B, I'm going to choose the project A. However, we are not going to use the IRR rule um, to make a decision about choosing the projects. We're always going to use our golden rule, which is the MPV rule. So now let's solve an example to see how that works. Assume that you own a small piece of commercial land near UTSA. You're considering what to do with it. You have been approached recently with an offer to buy it for $220,000. You are also considering three alternative uses of the land for yourself. You can either run a bar, a coffee shop, or an apparel store. You assume that you would operate your choice indefinitely eventually leaving the business to your children. You have collected this information, so how you can decide which project to choose. So you have three option: running a bar, running a coffee shop, or running an apparel store. And you also have the option to sell your land. So the MPV, or the benefit of doing any of these three projects, net of their cost, should be higher than the price that you can sell the land at. Okay, so in this table, I have the initial investment for each of these projects, and I have given a first cash flow, or the cash flow in the end of first year for each of these projects. And I also have a growth rate and the cost of capital for each of these projects. So now let's see how we can solve this question. The first thing that I'm going to do is to draw a timeline. So this timeline is based on the information that was given in the table in the question. So the table gives us information about the initial investment and the cash flow at the end of year one, and also a growth rate G, at which the first year cash flow will grow forever. Why I'm saying forever? Because the question assumes that we can run this business indefinitely, and it's eventually going to be run by our children. So, based on that information, I can write CF2 as CF1 multiplied by 1 plus G, and so forth. So if you just ignore the initial investment for the moment, and if you want to calculate the present value of all these cash flows that goes forever, we can use the growth perpetuity formula. So these cash flows represent the growth perpetuity, and we can use the present value of a growth perpetuity formula to value these cash flows at the time zero. So the formula, as you remember, is the present value of growth perpetuity is cash flow at time one divided by R minus G. R is the appropriate discount rate, or the cost of capital, minus the growth rate G. Okay, so now I don't need to use this regular NPV formula, because I can not decide where n ends. N does not end, it goes forever. So instead of this formula, I'm going to have another formula, which is this one. So uh, we have our initial investment plus the present value of all of these cash flow for each project. So for example, if I want to calculate the MPV for running a bar, it would be its initial investment of the bar plus the cash flow at the end of first year for the bar, divided by its cost of capital minus its growth rate. Okay, so in the next slide, I have calculated those numbers, and you can see it here. Okay, so for example, for the bar, the cash flow in the end of first year is 60,000, as you can see here, and then I divide that by its cost of capital minus its growth rate. Okay, and this $400,000 is the initial investment. So I use this formula that you just saw, so MPV for each project is its initial investment plus the cash flow at the end of year one divided by R minus G, which is its cost of capital minus its growth rate. Okay, so if I do that, I will end up with these numbers, which are the MPVs for each of these projects. And I also have the offer for buying the land. Okay, so there was an investor who wanted to buy this land for $220,000, and the MPV of doing each of these projects or running each of these businesses are as follows. So among these four options, the business with the highest MPV is coffee shop. Okay, so the MPV of running a coffee shop is 371,000, which is highest among all these options. So we should choose to run the coffee shop.